And now you know the content on the first page. All right, great. Okay, Chemistry 3111. Here we are in chapter 22. That means we've covered the big chapters 18, 19, 20, 21. And there are some reactions to memorize in this chapter. Oh, believe you me, there are. So if we go all the way down to the end of the chapter, you can see here, if I just kind of look at the review of reactions, oh boy, there's quite a few here. So look, we're going to cover all the reactions on here, preparation of amines. Then we're going to talk about more preparations of amines. Then we're going to look at more preparations of amines, reactions of amines. So what can you do with an amine now that you've made one? Then we're going to look at something called the Sandmeyer reactions, the CHEM reaction, reactions of diaryl salts. What else? Aryl diazonium salts again, azo coupling, and that's the end of it. So there's quite a few reactions in this chapter too, but it's not as lengthy as the other chapters. But let's get into it. And one thing I know you all remember from back in General Chemistry 1 is ammonia, right? NH3, you should know how to draw the Lewis structure of ammonia. You should know that when nitrogen is neutral, it has 3 bonds and 1 lone pair. You should know the molecular geometry of ammonia, which is trigonal pyramidal. And now we need to get into what are called primary, secondary, and tertiary amines. And those are governed by the number of alkyl groups that are on our nitrogen. So if we have 1 alkyl group on there, we call that a primary amine. If we have 2 alkyl groups, you guessed it, secondary amine. And you notice that both the primary and secondary amines, they have hydrogens attached to the nitrogen. And then kind of on the end here, I've got the tertiary amine, which has no hydrogens on the nitrogen. And why did I kind of leave that unto itself and put it in a different color? Because the tertiary amine cannot participate in hydrogen bonding in a pure sample. So something to keep in mind here. All right, if we have a naturally occurring amine, we call those alkaloids, and there are many, many, many alkaloids. There's some that I'm sure you've heard of before. I'm sure you've all heard of morphine before. And morphine is named after Morpheus, the god of dreams, and you can see that it's a potent analgesic. And what's really interesting about morphine is that you can modify its activity by modifying these 2 hydroxyl groups out here. And before I started recording today, I told my students that if you switch both of those hydrogens in the blue circle to acetyl groups, that would make heroin. So you take from morphine and you go to heroin, but you can make a derivative. You're thinking, well, that's dangerous. You know, you can make a derivative of morphine called etorphine, and I won't go over the structure right now, but you know, I think that only a few milligrams of that can tranquilize an elephant. So you can see how small changes in a molecule can have drastic effects. The next one is cocaine. Actually, this isn't technically, if you see cocaine in a movie or something, this isn't the structure of cocaine. When you see a white powder, it's actually the hydrochloride salt that you're looking at in a movie whenever you see a white powder or something. So cocaine, again, it's a base, right? It's an amine, but they sell it as a hydrochloride salt. But if you remove, right, if you deprotonate that, then you get the free base, and that's how crack cocaine is made. The next one is nicotine. So that's found in cigarettes, and it makes tobacco very, very addictive. Anyhow, and something else that you would know if you spent a lot of time studying organic compounds is that usually when you're dealing with compounds that have something to do with neurochemistry, they always contain a nitrogen, almost always here. You can see the structure of adrenaline here that has a nitrogen in it, and that's, of course, involved in the fight or flight response, noradrenaline and dopamine. And if you're wondering about dopamine, I think we talked about dopamine earlier on in the class, and you know, why can't you just give a person dopamine? That would make you feel a lot better. Well, the reason why is because it can't cross the blood-brain barrier. So we have, anyhow, I won't go into too much detail on that. And then, of course, you've got this compound here. This is methamphetamine. So methamphetamine. And the reason I put this in here is because I got asked about it so many times from my students. And before I started recording today, I was talking to the students about, you know, the difference between amphetamine and methamphetamine, and then pseudoephedrine and phenylephrine, and et cetera, et cetera. But anyhow, there's the structure of methamphetamine. You can see it's very closely related to a lot of these compounds on here. But let's get back into this whole idea of the molecular geometry of an amine. Whether it's ammonia, primary, secondary, or a tertiary amine, they all have a trigonal pyramidal nitrogen. And it says here, the nitrogen atom of an amine carries a partial negative charge on its lone pair, right? If you look at the structure of ammonia, for example, so we just look at the structure of ammonia quickly, right? You know that the nitrogen is more electronegative than the hydrogen, so we just put a delta minus on it, right? It's partially negative. It's not an anion, but it's partially negative. And because of that, that means that amines and ammonia can function as bases, right? Or as a nucleophile. Now this, an amine functioning as a base, this is something you should have seen about 780 billion times when you took general chemistry 2, okay? You would have seen this thousands and thousands of times in that class. So you should be very aware that if you take an amine, okay, and this one here is just a tertiary amine that they chose, and you put it in a strong acid like HCl, the equilibrium is going to lie entirely to this side where it's going to be completely protonated, okay? And you have to understand that very well in order to understand how an amine is going to behave in a strong acid, right? It's going to be protonated, and you end up with a salt, not table salt, it's not sodium chloride, but you get a salt. You get a cation and an anion. So let me ask you a question. Let's just test our knowledge here, okay? If we compare the water solubility of a tertiary amine versus a salt, go with your gut. Which one of these do you think is going to be more soluble in water, generally speaking? A salt, exactly. And so that is why we protonate amines when we want to put them in an aqueous phase. And we're going to talk about the extraction of amines in a little bit. But there you go. So that's how an amine can function as a base. But an amine can also function as a nucleophile. And this is a reaction we're going to see, is that amines are actually make dandy nucleophiles if you have a strong electrophile like chloromethane or something like that. And then you can end up with what? What's this again? This is a salt, right? If you have a positive charge and a negative charge, you've got yourself a salt. This is just an electrostatic potential map of this is called trimethylamine. So you can guess where that name comes from. It's got 3 methyl groups on it. So trimethylamine. And if you look at the electrostatic potential map, the region where it's red in the center, that shows the high region of electron density. Okay, so you can see that most of the electron density lies on the nitrogen. But before we can get into talking about amines and amine this and amine that, okay, we got to talk about the nomenclature of amines. And this is going to take a little bit of time because we have to talk about the nomenclature of primary, secondary, and tertiary amines. We start with primary, and then once we cover all those rules, we add secondary and tertiary to it. So let's get started with primary. And it says IUPAC nomenclature allows for 2 different ways of naming primary amines. One is if you can identify the alkyl group. So if you can, it says name the alkyl group. So this is if it's an alkyl group that you know. So what are the alkyl groups that we know in this class? There's 8 of them: methyl, ethyl, propyl, isopropyl, butyl, terbutyl, sec-butyl, isobutyl, right? So if it's one of those, you could just name that alkyl group, follow it by -il, of course, and then put the suffix amine. So here we have an ethyl group, so you have ethylamine. Here you have an isopropyl group, isopropylamine. Well, I guess you also know cyclohexyl, so cyclohexylamine, cyclobutylamine, cyclopentylamine, et cetera, et cetera, et cetera. And I'll just be honest with you, chemists love common names. So if they can identify a common root or a common alkyl group, they will do it. Now, we can also name these as using IUPAC nomenclature, or systematic nomenclature is what I should say. And I'm going to come back to that in just a few seconds. But if you have a more complicated amine, right? Here's a primary amine, but you can't give a name to all this spinach here. In that case, you name it kind of the same way you do an alcohol. What you do is you find the parent chain that contains the amino group on it, the NH2 group, and you name all of that, and then you call it an amine. So here you see the longest carbon chain that contains the functional group is 7 carbons. So that's some kind of heptane. So since the amino group, the NH2 group, which we call an amino group, is on carbon 2, we call it 2-heptane amine. All right. So that's how we would do that. So if we go back, I just want to make sure that we try it out here. So let's say you wanted to give the systematic names for these compounds, right? You would call this, right? The longest carbon chain is 1, 2. So you'd call this ethane amine. Okay, that would be, again, this is systematic. And the names up here, these are common names, or we just name the alkyl group. So for this one here, you see the longest carbon chain has 3 carbons in it. So this would be 2-propanamine. So 2-propanamine. And one of my students asked me one time, could you call it propane 2-amine? And the answer is yeah, you can do that. That would be accepted too. And then we have cyclohexylamine. So for this one, right, the longest carbon chain, well, it's right. If it's a cyclic alkyl group, whatever, if there's only one substituent, you don't have to give it a locant. And so we would call this cyclohexanamine. So cyclohexanamine. Anyhow, just a little practice on both there. So let's go over here. And like you heard the word amino slip out of my mouth a bunch of times. And that's related to what's called the hierarchy or the order of precedence of functional groups. And it's something we don't talk about a lot, but it is in the appendix of our textbook. And I think I copied this right out of there. You see that carboxylic acid is the king of the castle, followed by aldehyde, ketone, alcohol. And then you see nitrogen is below that. So what that means is if you had a compound that has an alcohol in it and an amine, you would say the compound is an alcohol. So you would name it as an alcohol. And when you have an NH2 group, it's like a methyl ethyl, you call it an amino group, okay? So 4-aminobutanol, right? So if we look at the longest carbon chain, 1, 2, 3, 4. So this is butanol, so you have 4-aminobutanol. Here your parent would be benzoic acid, and you would call this para-aminobenzoic acid. This is PABA, P-A-B-A, if you've ever heard of that before. Or you could call it 4-aminobenzoic acid, the same thing. All right, so basically, kind of what I'm getting at with this putting the order of precedence here is that anything with oxygen is going to take a higher priority than nitrogen. All right, and we don't spend a lot of time naming bifunctional compounds in this class, but it is something you should be aware of. I mean, this is second semester organic chemistry, so you should see it a little bit. Next thing is if your amino group is attached directly to an aromatic ring, that's some derivative of aniline, and you had to memorize the structure or the name of aniline quite a while ago. And so this compound here, we could call this metachloroaniline, or you could call it 3-chloroaniline. Here you want to give the substituents the lowest possible numbers. So you would number counterclockwise, 1, 2, 3, 4, 5. So you have 5-ethyl, 2-fluoroaniline, et cetera, et cetera. So before we can finish up the section on naming amines, I told you now we've covered primary amines, but we also have to cover secondary and tertiary amines. Now just follow along the rules here. It says, first thing you do is you name the alkyl groups and you cover it or you end it with the amine suffix. Use di and tri if there are more than one of the same group. So this is something we do if we have all alkyl groups that we know, right? Everybody who's hearing the sound of my voice, I know everybody knows what an ethyl group is. I know everybody knows what a methyl group is, and I know everybody knows what a propyl group is. So you list them in alphabetical order. You list them from A to Z, and so you have ethyl methyl propyl, EMP, ethyl methyl propylamine. If you have two of the same group, right? This is an ethyl, this is an ethyl, so you use diethylamine. You can imagine if you had 3 of them, I'll just draw it here. And I know you all know what the answer is, right? If you had this compound, you would call this triethylamine, right? Just like here, we have trimethylamine. Anyhow, there's some interesting properties that trimethylamine has that I won't get into right now. Okay, so that's how we name secondary and tertiary amines if they have alkyl groups that we can name, right? These are little alkyl groups, the 8 alkyl groups that we know. Okay, so what happens if you have some kind of parent that is way bigger than an ethyl or a methyl or a propyl, et cetera, et cetera? In that case, what you do is you're going to name it as an amine, right? So you can see the longest carbon chain here contains 6 carbons, so we would call this a 3-hexanamine, right? It's the same thing that we learned with the rule for naming, for giving a systematic name to a primary amine. But all you do is just name these groups as substituents. So if you have a methyl group, you write a capital N, and it's usually italicized on the computer. Obviously, you don't have to do that if you're writing it out in pencil. So you have N-methyl and N-ethyl, and you list those in alphabetical order, alphabetizing according to the letter M and the letter E. You ignore the N, which is a prefix. So N-ethyl, N-methyl, right? Now here we also have a 2,2-dichloro, and C comes before E and before M. So we have 2,2-dichloro, N-ethyl, N-methyl-3-hexanamine. And of course, you have to put the stereochemistry there. And I know you know how to assign R and S. I have no doubt in my mind about that. So if we go to this problem here, okay, there's a couple of ways we could name this. We could name this using the systematic way, or we could name it using the common way. So if we try using the common way, right, we know that this is a methyl group, we know this is a methyl group, and we know this is a cyclopentyl group. So we have cyclopentyl dimethylamine is what you would call this as a common name. So I'm just going to write it down here for you. So let's see here. If we were to name this as a common name, we would say cyclopentyl dimethylamine. Now that's the common way of naming it. If we were to use the systematic way, so systematic, in that case, what we're going to do is we're going to find the longest carbon chain, right, which is the 5 atoms in this cyclopentane ring. So this would be some kind of cyclopentanamine, right? But now we've got an N-methyl and an N-methyl. So we say NN-dimethyl is the way you put that. You don't put N-methyl, N-methyl. You would say NN-dimethyl cyclopentanamine. Comme ça, as we say in French. Could anybody give me a common name of the next one? Oh, we already did this one. Sorry, my mistake. I did this one on a previous slide. This is triethylamine. Triethylamine. We actually have an acronym for this one. We call it TEA sometimes. Could anybody give this one a systematic name, though? Right, the longest carbon chain has 2 carbons, so it would be an ethanamine. Right, and then it has N-ethyl and N-ethyl. So the systematic name would be NN-diethyl ethanamine. Now, I worked in a lab most of my adult life before I became a teacher. I worked as an organic chemist in Big Pharma for about 15 years, and I've used triethylamine thousands of times. And I can tell you right now that if somebody said to me, hey, where's the NN-diethyl ethanamine? I'd say, what? What is that? Or, I mean, I would be able to figure out, but I'd be like, what kind of a weirdo? You know, who would say that? Okay. So usually, again, if we can come up with a common name, chemists love common names. All right. Let's try the last one. It's got 2 chiral centers in it. So this is some kind of cyclohexanamine, okay, because we have an amine on here. And we want to give the substituent the lowest possible number. So we're going to go like this, 1, 2, 3. So we've got 3 isopropyl cyclohexanamine. So 3 isopropyl cyclohexanamine. Like that. Now we need to figure out the chirality at chiral center 1 and chiral center 3. Did anybody figure out whether chiral center 1 is R or S? So I mean this chiral center right here. Tiana, did you get this one? Or anybody? Mary? Nicole? I'll just keep yelling out names. All right. Somebody get R, somebody else get S. Oh, let's do it as a group. Let's just scribble in the hydrogen in the back. So we're going to go, the nitrogen's going to be number 1. This is going to be number 4. Right here we have a CH2, but that's attached to just a plain old carbon. Did I put CH2 in a minute? There we go. And then this one here is attached to a carbon, which is attached to a carbon. So this is going to be second highest priority. This will be third. So we go 1, 2, 3 like that. So this is 1s. Let's scribble that down. It's 1s. Let's try the other one. Anybody get the second one? The second one. 3 what? Well, let's do it as a group. Oh, Nicole, Che, Lynn. Okay, they are all saying R. They're probably right. So we're going to start. So this carbon is attached to carbon, carbon, hydrogen. This carbon is attached to carbon, hydrogen, hydrogen. This one. So it's going to go like this, like what? 1, 2, 3, like that. So that's going to be R. Sounds good to me. So 1s3r. Thank you very much. And there we go. So we've named some amines. Gets a little bit of practice on our con-angled pre-log rules. Let's try a couple more problems, and we'll take a short break. Just draw the structure of each of the following compounds. So if I have tricyclobutylamine, that means I have to draw three cyclobutanes. I hate drawing cyclobutane. You're like, why do you hate drawing a square so much? Because I always find the ones that have this angle, I'm good at. But then when I have to draw this one here, I have to turn the iPad. And how would you do it? Like this? Mr. Dion is not much of an artiste. Man, doesn't look that great. But anyhow, there you go. Give me a thumbs up if you follow me on tricyclobutylamine. Everybody with me on that one? Okay, good. All right. Let's see, 2,4-diethyl aniline. So we're going to start out by drawing aniline. I know you can all draw that in your sleep. So you draw an aniline molecule. And then we put 2,4-diethyl. So we're going to number starting here. This is 1, 2, 3, 4, 5, 6. So on carbon 2 and 4, we'll put ethyl groups. So 1 here, 1 there. Oops. That. Oh, jeepers, the last one's got chiral centers in it. Did I ever show you my trick for drawing a compound with chiral centers? 1R2S 2-methylcyclohexanamine. This is how I do it. I draw the compound, and I always put every chiral center pointing down. So here's my amino group. Here's my methyl group. I put everything pointing down, and then if it's wrong, I just shade it in. So 1, the way I have it drawn, is it R or S? It goes from 1, 2 to 3. So it goes this way, which is clockwise. I would reverse it. So that would be S. And it's supposed to be R, isn't it? Yeah. So I'd shade this one in. Oops. So I'll color that in like so. So I fix that one. And the chiral center in the second one, I'm going to go from 1 to 2. No, sorry. So my hydrogen's coming up, so I'm going to go from 1 to 2 to 3. So I'm going like this, which is, what am I doing wrong here? So I have hydrogen coming out. Yeah. So this is drawn as R, isn't it? Yep. So I'd have to shade this one in too. Like that. There we go. Does that look better? I'm sure somebody who's hearing the sound of my voice did this problem already. Okay. All right. Well, it looks right to me. Anyhow, all right. So what we're going to do now is we're going to take a short break before we tackle the section on properties of amines. So we're going to talk a little bit more about bond length and bond angles and the molecular geometry. We're going to talk about acidity and basicity and hydrogen bonding. What else is covered? Yeah, just a few of those kinds of things. So we'll get into that, and then we'll get into the reaction. So we have one more short section to cover before we get into the section on synthesis.